IDC has been tracking the total amount of data created worldwide every year for nearly a decade. This year alone, over 13 zettabytes, that's 13 million petabytes of new data will be created, captured, or replicated throughout the world. That's an average of 415 terabytes of data per second, or the equivalent of more than 3,000 of today's hard disk drives every minute. This data comes in many forms, both structured and unstructured. By 2020, the total amount of data created will reach 44 zettabytes, and 80% of it will be unstructured in nature. IDC expects the amount of unstructured content to reach 35 zettabytes over the next 4 years, as companies manage through 3 key trends. First, an increasing number of regulations and laws require the retention of a broader range of electronic data. For example, regulations now stipulate the retention of not only email and instant messages as forms of electronic communications, but also stipulate the retention of public and enterprise social communications that occur over social networks. The increasing number of ways data is being created and captured through a myriad of new devices, as well as the Internet of Things. Much of this data being created is human or machine generated and facilitated by companies participating in the software economy. Companies such as LinkedIn, Uber, Airbnb, Yahoo, Netflix, Apple, as well as various government organizations that are supporting massive repositories of content. And lastly, the increasing appetite for information and services to be delivered by corporations, line of business managers, business to consumer, and government to citizen engagements. IDC refers to this new economic segment as value-added content providers that create or add value to large information sources. The storage industry is responding to this massive data growth by offering new storage platforms and architectures designed to help organizations balance compliance needs, storage costs, and performance requirements. These include, increasingly, the use of flash to augment or replace high-performance hard disk drives, as well as cloud-based storage as a service offerings that are used as an alternative to or in combination with on-premise storage infrastructure investments. Also, software-defined storage and the ability to decouple management and persistence from the underlying hardware. And lastly, the convergence of compute and persistence for performance, management, and efficiency gains. Forward-looking CIOs are looking to maximize the effectiveness of their storage environments, investing in flash as a persistence tier. This starts with prioritizing workloads that are candidates to move to flash, such as latency or performance-bound workloads, then measuring the performance gains realized and moving to the next workload in the queue. We're also starting to see the use of flash for high-capacity workloads, including object-based storage systems. Also, developing an information map for applications or content that need to be retained but are fixed in nature. Increasingly, we see firms considering cloud or object-based storage approaches for inactive as well as active data. And lastly, using object-based storage as the foundation for public, private, and hybrid clouds today, for both traditional as well as born-in-the-cloud applications and services that take advantage of technologies like mobility, big data, artificial intelligence, IoT, and social to create new business value. Object-based storage is a key software-defined storage approach. The benefits include scale-out capabilities, resiliency without RAID, metadata awareness, and the geodispersal of data. It's because of these attributes and more that object-based storage systems are the foundational element, the third platform of cloud computing environments today.